Astronomy is the oldest science. Thousands of years ago, observers moved their eyes across the stars and drew outlines of familiar figures, transforming the sky into a vast picture book. As early stargazers watched the constellations, they noticed among them certain star-like objects which seemed to wander. This motion supplied the Greek name for them, planets, the wanderers. Awed by objects that moved through the sky, men attributed great powers to them. They plotted their paths, used their motions to foretell the future, and venerated them as gods. Mars, symbol of war. Venus, goddess of beauty and love. Mercury, the divine messenger. Jupiter, supreme god of gods. Saturn, protector of agriculture. To the 5 planets known to ancient man, modern astronomers added 3 more. 9 planets, including Earth. No longer gods, but places to be explored. Twentieth-century man has grown accustomed to seeing his own planet from space. In a flicker of time, he can monitor its passage from day to night and its ever-changing clouds suspended in moving layers of air. The one feature which makes planet Earth unique in the solar system, its atmosphere, with its life-supporting ingredients, oxygen from the plants and moisture from the seas. Although essential to life, the atmosphere is an obstacle to astronomers. Trapped in its moving layers, dust and other impurities hinder observations into space. In spite of this handicap, men search the heavens, hoping to find other Earths. Among the other planets, Mars, a neighbor of Earth, seemed the most likely. In 1877, Giovanni Schiaparelli, peering at the planet 35 million miles away, made the startling claim that a network of regular lines crisscrossed the Martian surface. Like other astronomers in the days before widespread photographic astronomy, he sketched the lines that he called canali, meaning channels in Italian. Improperly translated from the Italian, channels became canals in English. Half a century later, Percival Lowell, an American astronomer, thought he had found canals. Going one step further than Schiaparelli, he even mapped and named them. Other scientists questioned these findings, but science fiction writers ran wild, setting off one of the gaudiest episodes in the history of astronomy. Mars, with its canals, became a world teeming with bizarre forms of life. Low-gravity forests inhabited by tall, spindly creatures. Warriors in constant battle. Gentle, man-like Martians. H.G. Wells conjured up feathered Martians, half human, half bird, and octopus horrors with huge brains vastly superior to man's. Martian creatures passed into planetary folklore, but Schiaparelli's canali continued to haunt Earth-bound observers. Photographs have revealed smudgy lines, but they have never recorded the details drawn by Mars observers such as Schiaparelli and Lowell. Not even photographs taken at the same time that details were sketched. But photographs provided clearer views of another baffling surface feature, a drifting wave of darkness. As Martian winter slowly changes to spring, slightly dark areas in the central region spread and become darker. Some thought this darkening represented the growth of living things, like plants. Equally puzzling were the large white areas in the polar regions which recede with the oncoming of the Martian summer. Could they be melting snow and ice fields? If so, what happens to the water? Does it evaporate into the Martian atmosphere? With powerful instruments, like this one, on Kitt Peak in Arizona, astronomers can measure and analyze the composition of the invisible atmospheric blanket surrounding our neighboring planet. Reflected sunlight from the surface of Mars, the only light which makes planets visible, passes through mirrors to be spread into its different colors or wavelengths, indicating the chemical elements of its atmosphere. The findings could only disappoint those who sought life on other planets, for the Martian atmosphere is very thin, with carbon dioxide predominating, and hardly any water. No atmosphere suitable for vegetation. The 1960s freed astronomy from the limitations of earthbound observations. In 1964, equipped with a telescope and a television camera, Mariner 4 headed for Mars. Its mission? To take close-up pictures, which would, hopefully, resolve the mysterious wave of darkness and other unanswered questions. After traveling for 8.5 months toward its moving target, the camera photographed the Martian surface at a distance of only 6,000 miles. The pictures arrived on Earth as a numerical code. The computer, without which modern space research would be impossible, translated it into the first close-up photographs ever taken of another planet. These views showed neither canali nor clues to the wave of darkness, but they did reveal something else quite startling. A surface dotted with craters, some of them more than 100 miles in diameter. Looking nothing like Earth, Mars' pockmarked exterior was more like the moon. In addition to the photographs, Mariner 4 accomplished another first in space astronomy by beaming radio waves directly through the atmosphere of another planet. The density profile sent back to Earth revealed that the Martian atmosphere is 15 times thinner than had been assumed. Mariner 4 lived up to the scientists' expectations, but it had a limitation. Its cameras could not define surface features less than 2 miles in diameter. Astronomers were anxious for a closer look. The next Martian probes more than offset this handicap. Early in 1969, Mariner 6 and 7 began 2 unprecedented space missions. Launched a month apart, they were to investigate the wave of darkness and the South Polar Cap. Astronomers, astrophysicists, engineers, geologists, geophysicists, biologists stood by, waiting for theories to be proven or disproven, and for possible surprises. As Mariner 6 approached the planet's equatorial region, its camera system went into operation. Close to the surface, details as small as 900 feet in diameter were recorded. Again, no pictorial evidence of the wave of darkness emerged. Five days later, Mariner 7 sent back its findings from the polar cap, which upset the melting snow and ice theory. The cap consisted primarily of frozen carbon dioxide, or dry ice. The new Mariner photographs detected another unexpected surface feature. A maze-like mixture of jagged cliffs and steep ravines covering hundreds of thousands of square miles, which scientists labeled chaotic terrain. To combine all the Martian explorations on a 24-hour basis, a global network of scientific stations, a planet patrol, was set up in 1969. Telescopes in widely scattered locations make photographic records as Mars comes into view. At Flagstaff, Arizona, scientists coordinate their observations with those of their colleagues in other parts of the world. Taken with the same kind of equipment, photographs from all Planet Patrol stations are interchangeable. They can be compared to provide a round-the-clock record of Mars' changing surface features. A grid can pinpoint any area under study. The still unexplained wave of darkness, the discoveries of craters, chaotic regions, polar caps of dry ice, an atmosphere 200 times less dense than Earth's, make Mars a place completely different from what scientists thought it to be just a short time ago. As Mars orbits on the far side of the Earth, another planetary neighbor moves in its orbit closer to the Sun. Venus. Brightest object in the night sky except the moon. Because of its brightness, astronomers expected to see Venus clearly. But as with Mars, their expectations influence their findings. Some 19th century astronomers imagined that Venus had at least one Earth-like feature, oceans. This led to further speculations. Where there is water, there must be vegetation. And where there is vegetation, there might be a higher form of life. But the only really visible feature was a dense bank of clouds hiding the planet's surface. When Venus came between Earth and the Sun, the thick carbon dioxide atmosphere surrounding the planet became visible as a fuzzy halo. But what about the surface? There was a way to penetrate both cloud cover and atmosphere: radio waves. In the middle 50s, at the Naval Research Laboratory in Washington, D.C., astronomers converted a naval gun carriage into a radio telescope mount and aimed it at Venus. The temperature of Venus' cloud deck had already been estimated at minus 40 degrees Fahrenheit, not too different from that above Earth. Was Venus like Earth, as many suspected? The radio waves supplied a clear answer. It wasn't. A minimum of 620 degrees Fahrenheit were measured on its seething surface. Lead would melt. Blood would boil. Venus' closeness to the Sun could not explain the enormous temperature. There had to be another reason. One possible explanation, the greenhouse effect. Sunlight passing through the roof is absorbed by both ground and plants, but the radiated energy is trapped by the greenhouse's atmosphere and its glass roof. Heat builds up. Could Venus be one giant greenhouse? Again, Earthbound observations could not provide the answer. In the early days of space exploration, manned balloons were put into service. At 90,000 feet, above almost all of the Earth's atmosphere, sensitive infrared detectors measured the clouds surrounding Venus. Surprisingly, these and later readings indicated ice crystals in the cloud deck on top of the atmosphere. Ice crystals which might be acting as a greenhouse roof, trapping the planet's heat. Was Venus roasting under ice? a spacecraft confirmed the vastly different temperatures of the planet's hot surface and its frigid cloud deck. Subsequently, another spacecraft, Mariner 5, measured the Venusian atmosphere and its cloud cover from its vantage point. But it was not alone. 24 hours earlier, a Soviet spacecraft, Venera 4, parachuted an instrument package on a collision course with the planet's surface. Descending below the cloud deck, gas analyzers determined that the atmosphere consisted almost totally of carbon dioxide. Then the signal stopped. Scientists theorized that the instrument package either melted or was crushed by the heavy atmosphere. All these studies contributed to a theoretical picture of Venus. An undulating landscape, a sky constantly overcast, a surface scorched by temperatures up to 800 degrees Fahrenheit, an atmosphere 100 times more dense than Earth's, and above it, a frigid cloud deck, possibly containing ice crystals. This cloud deck, together with the atmosphere, could create the greenhouse effect. Venus was nothing like anyone imagined. The facts that emerged were more what astronomers had expected to find on another planet, Mercury. Closest to the Sun, Mercury should be the hottest planet, yet it is not. Its temperature is lower than that of Venus, for hardly any atmosphere surrounds it, too little to permit a buildup of heat. For many years, astronomers thought that Mercury always presented the same face towards the Sun, while the other was eternally dark. Since it is known that Mercury revolves around the Sun in 88 days, it would have to rotate around its own axis in the same amount of time. But in recent years, astronomers questioned this theory. Carved out of the mountains of Puerto Rico, a giant 1,000-foot antenna helped to supply the answer. Radar signals, like those used by a traffic policeman to check the speed of passing cars, were sent into space to detect the speed of a planet. The reflected signals revealed that Mercury was rotating around its own axis every 59 instead of the previously assumed 88 days. The same side could not always face the Sun. Hundreds of millions of miles further out in space, away from Mercury and the other small inner planets hugging the Sun, giant Jupiter dwarfs them all. About 700 times the volume of all the inner planets put together, it ponderously revolves with its satellites in its 12-year journey around the Sun. As with the other planets, astronomers tried to photograph Jupiter's surface, but it too was obscured by multicolored bands of swirling gas clouds. This atmospheric turbulence is partially caused by the planet's incredibly fast rotation around its own axis, a complete rotation in just under 10 hours. The dynamic atmosphere is accompanied by another phenomenon, gigantic bursts of radio energy received on Earth by radio telescopes like this one at Jodrell Bank in England. A single 1-second burst releases radio waves equivalent in energy to those generated by 1 billion earthly strokes of lightning. Astronomers theorize that below Jupiter's heaving cloud cover, there is no surface, no solid body of sand and rocks, only a mixture of thin, light gases. Under atmospheric and gravitational pressures, the gases liquefy and further down become denser and denser to finally solidify. Jupiter's next neighbor in space is, at its nearest, 500 million miles away, the most spectacular of all, Saturn. Like Jupiter, it is gaseous and enormous, but much less dense. Made up almost entirely of hydrogen and helium, Saturn would probably float in water. But the feature that sets it apart from all the other planets is its rings. One view of these rings showed them to be thousands of miles wide. Astronomers concluded that the rings consisted of tiny particles, no bigger than grains of sand, covered by ice crystals made visible through shifting shadows produced by the rays of the sun. As Earth and Saturn move around the sun, views of the rings change. Sometimes they disappear completely. The disappearance from view of the particle-laden rings in predictable intervals has resulted in a convincing theory. The rings are so thin that their knife-edged sharpness makes them invisible. Saturn was the most distant of the heavenly wanderers known to ancient man. It took thousands of years to locate the next one. The determination of a German musician turned astronomer to the English court, William Herschel, brought about this discovery in the late 18th century. Sighting a faint disk among the stars, he studied its motion across the sky and realized he had discovered another planet, Uranus. This discovery set in motion a series of other discoveries. Uranus, 1 billion miles farther away from the sun than Saturn, did not travel in a predictable orbit. The French mathematician Leverrier concluded that the gravitational interaction with another planet could be the cause. He even predicted its location. Using Leverrier's prediction, a German astronomer, Galle, found the missing object in 1846, way beyond Uranus. Another gaseous giant, Neptune. But its mass was not sufficiently large to explain all of Uranus' erratic motion. 70 years later, Percival Lowell, the proponent of the Martian canals, thought he had found an answer by mathematically predicting the orbit of another planet, which he called Planet X. He died before he could locate it, but his prediction gave impetus to others to pursue the search. Clyde Tombaugh, still studying planets in the 1970s at New Mexico State University, discovered the last planet in the solar system. In the 1930s, at Lowell Observatory in Flagstaff, Arizona, he used this telescope to look for the elusive Planet X. A farmer, amateur astronomer, later turned professional, he systematically photographed the night sky. Using the fixed stars as guides, he examined pairs of plates looking for a small shifting star image. After many months of study, Tombaugh finally found one that seemed to fit the requirements. On two famous plates taken on the 23rd and 29th of January 1930, his perseverance was rewarded. A shift of 1/7 of an inch indicated a moving object that could only be Planet X. It was called Pluto. The facts about this planet are few. Its voyage around the sun takes a long 248 years. It is small, only half the size of Earth, and solid rather than gaseous. On the edge of the solar system, this planet is cold and dark, a dim object lost among the stars. It is obvious that the outer planets, billions of miles in space, will not yield their secrets to Earthbound observations. But in the late 70s, scientists will have a unique opportunity for an unprecedented close look at the gaseous giants. Roughly every 179 years, the planets align themselves, permitting an unmanned spacecraft to make a grand tour of inspection. The beginning of the journey will be a familiar one. Lifted free of the Earth's gravitational pull by multi-stage rockets, the spacecraft's powered flight will last only 12 minutes. After the last stage rocket pushes the spacecraft on its way, it will then make the rest of the journey without any forward thrust. Only one small onboard rocket will make slight course corrections. Then, panels will open to capture the sun's energy to help operate its instruments and communicate with Earth. Animation generated by a computer has simulated such a 9-year journey. As the spacecraft nears its first target, Jupiter, its speed is increased by the planet's enormous gravitational pull. 1.5 years after takeoff, the instruments begin transmitting information about the planet's elusive features, its swirling cloud bands, hidden surface, and gigantic bursts of radio energy. Then, deflected by Jupiter's mass in this grand game of interplanetary billiards, the spacecraft is passed on to its next target 2 years away, Saturn. By the time its instrument readings and photographs of the mysterious rings and other features are received on Earth, the spacecraft will be swept on the third leg of its journey, to Uranus. The only planet which spins on its side, its satellites moving around it like passengers on a Ferris wheel. Uranus, this tiny speck in the sky as seen from Earth, may on close inspection yield some revelations about its unique features. The next stage of the trip will take another 3 years. As very little is known about Neptune, the last of the giants on this tour, astronomers hope that the close-by instrument readings will provide some facts about the planet's surroundings and composition. And so, billions of miles from Earth, the spacecraft, its instruments dead, its mission fulfilled, may end up in orbit about some distant star. Man's exploration of the other planets has resulted in greater concern for his own, Earth, the only oasis in our planetary system. But the feature most essential to life on Earth, its atmosphere, is changing through the interference of man. Increasing amounts of carbon dioxide surround us, the same gas which contributed to making Venus a seething wasteland. It is well within reason that if man continues to abuse his environment, Earth, too, may become barren like its sister planet. If we can draw any conclusion from our explorations of other planets, it is that man is alone in the solar system, that he alone can conserve those ingredients which make Earth a planet of life.